It's just after 10 o'clock on the 29th of March, and one of the biggest astronomical events of the year is about to begin. Welcome to the Royal Observatory Greenwich's partial solar eclipse watch. I'm Dr. Greg Brown, and we are going to be bringing you the best view that we can of this partial solar eclipse as it unfolds over the course of this morning. Now, we are going to be observing the eclipse with our own solar telescopes here at the Royal Observatory throughout this morning, bringing you the best view that we can. If you want to observe the eclipse for yourself, we're also going to have hints and tips on how to do that. The main thing is do be safe. Don't go looking directly at the sun. It's very dangerous to do that. The partial solar eclipse itself is going to begin in just a few minutes' time. I'm going to be bringing you that to you in just a moment, with the expected peak at just after 11 o'clock. And then after that, we're going to go to a quiet stream where we're not going to be talking anymore, but for the entirety of the eclipse, all the way through till just after midday, we're going to be bringing you those videos, that image, the entirety of the time. Now, the weather here today is looking pretty good, so we're on track for being able to see things. Now, for us today, we're going to be using a particular solar telescope to observe the solar eclipse. And to explain more about how that's going to work, here's the man who's going to be operating the telescope for you, Jake Foster.
View the partial solar eclipse. It is a Lunt 4-inch solar telescope. 4 inches refers to the aperture. That is the diameter of the objective lens right up here at the top. That is where the sunlight is gathered in. 4 inches might not sound like a lot. You may have seen much bigger telescopes before, but the sun is big enough and bright enough that this is more than enough for the job. It is a specially designed solar telescope built to observe the sun. And we should stress that you should never look at the sun with a conventional telescope or pair of binoculars. They are not built for it, and your eyes aren't built for it either. It simply is not safe. This telescope has 3 key features that make it safe for viewing the sun. Firstly, it has a blocking filter in it that takes the light from the sun and removes 99.9999% of it. Only then is it safe for us to view it. And also it has a hydrogen alpha filter that takes that tiny portion of light and narrows it down to a very specific wavelength that can help us to see certain features on the sun, such as filaments and prominences, things that we'd like to be able to show you. And as well as that, the components within the telescope have a heat-proof coating on them. That means that they won't be damaged by the sun's heat, because not only are we bringing in sunlight, we're bringing in the sun's heat as well. Now, usually at the end of a telescope you might be used to seeing an eyepiece so that you can look through it and see whatever's coming in the other side. On this occasion we have a camera in there. That camera will be filming the eclipse live as it happens, and we'll be sending that view through to you so that you can watch it with us. The one thing this telescope cannot do is see through clouds. So we hope that it'll be nice and sunny like it is right now on the day of the eclipse right now when you're watching it. But either way, stick with us as we follow the eclipse from right here at the Royal Observatory Greenwich.
That was Jake Foster there talking to you about the solar telescope that we are going to be using today, which you can actually just see over my right shoulder here. We're going to be bringing you the best view that we can of the solar eclipse during this partial solar eclipse today. Now, the partial solar eclipse will be beginning in just a minute or so. You should be able to see down in the bottom corner of your screen, there is actually the view that we're getting through our telescope at the moment. It's a beautifully clear day, so we're very much hoping that we're going to have an excellent view of the solar eclipse. Now, the eclipse is not visible from the entirety of the world, only from certain parts of it. And we've today partnered with timedate.com, who have provided us with a fantastic map of where the eclipse is visible from. And it turns out that for this particular one, for the most part, it's in rather uninhabited parts, or sparsely inhabited parts of the world. So northeast Canada in particular, Greenland, there is a view in Iceland, the very northeastern part of the USA, and of course across the northwest of Europe as well. And the different parts of the world will see a different amount of the sun being covered up. Now, this isn't a total solar eclipse, so nowhere on the Earth is going to actually see the entirety of the sun being covered up in that rather stunning display that occurs when the moon completely covers the entirety of the sun. That's just not going to happen this time. But even in the parts of Canada that have the best view of it, it's still only about 90%, which is pretty good, but it's not quite totality. Now, I mentioned that we have partnered up with timeanddate.com, and they are both receiving our own stream and sending us a whole series of streams from other parts of the world as well. We've got feeds coming in from St. John in Canada, from Tromsø and Kristiansand in Norway, and Siena and Genoa in Italy, along with their own roving telescope, which I believe is in Denmark at the moment. So they are going to be bringing us also views of whatever they can see through their telescopes, and if for whatever reason we suddenly end up overcast and we're completely covered out and we're not going to be able to see anything, then hopefully we'll be able to bring you a view through their telescopes instead. While all of this is going on, we are also having observing actually happening here at the Royal Observatory Greenwich, with our visitors able to look through some of our solar telescopes for themselves. And to tell you a little bit more about that, here is Mike Maynell from Flamsteed Astronomy Society.
I'm here with Mike from Flamsteed Astronomy Society here in Greenwich. Thank you for looking at our telescope for a second there. Can you just tell me a bit about what you're doing here and maybe your telescope?
Yeah, sure. So we are here today to do one of our public solar viewing sessions. We're using a specialist hydrogen alpha telescope to see surface features on the sun that you can't normally see. But we've got the added bonus today, of course, of the partial eclipse. So we're hoping to see that nice bite taken out of the sun for about a couple of hours or so, from just after 10 o'clock up until midday. And we're expecting to be very busy.
Very nice. Can you just tell me a little bit as well about Flamsteed Astronomy Society and what you do?
Sure. So we're the Amateur Astronomy Society, which is based here at the Royal Observatory Greenwich. Anyone can join the Flamsteed. We do lots of events during the year, lectures, talks, workshops, plus lots and lots of observing events. So we have this observing event here today. We've got one on Blackheath tomorrow evening. So if anyone wants to see the crescent moon after the eclipse, you'll be able to see that tomorrow evening on Blackheath if you come and join us.
Thank you, Mike.
Mike Maynell there from Flamsteed Astronomy Society. Definitely worth joining if you are interested in seeing some of the sights from this part of London. Now, let's have a look at our view through our solar telescope. When I've just been informed, we do in fact have first contact has actually occurred. So if you look down in about the 5 o'clock position around the sun, you can see a tiny, tiny bite appears to have been taken out of the side of the sun. That is in fact the moon starting to encroach upon the disk of the sun to block some of its light. We're seeing that in silhouette. Now, we're expecting around about 30% of the sun to be hidden behind the moon at its peak, which should occur in almost exactly an hour's time, just after 11 o'clock. Now, we've been talking a bit about these eclipses, but what exactly are they, and why don't we see them all the time? Well, in order to help with that, we've got a rather handy animation to show you exactly how eclipses actually work. So what is an eclipse? An eclipse is when the moon passes in front of the sun, blocking out some of its light and making it so that it appears that the bite has been taken out of the sun. We're just going to bring up that animation for you right now to show exactly what the solar eclipse actually how it actually occurs. So the moon is constantly orbiting around the Earth, and they're roughly in plane with one another, so sometimes the moon will actually come directly between the Earth and the sun, blocking out some of its light. Now, if things are perfectly aligned, then while the sun is 400 times larger than the moon, 400 times wider, it's also 400 times further away, which means we end up with this fantastic coincidence where the moon can actually block the entirety of the sun's light for a small region on the surface of the Earth, the people who are underneath the shadow of the moon. Now, we aren't going to be having a total solar eclipse today, so what you're about to see with this rather fantastic view when the entirety of the sun disappears, that's not going to be happening today anywhere on the Earth, so you're not missing out on that. Instead, we're going to have a partial solar eclipse. In rare situations where the moon is slightly too far away to cover up the entirety of the sun, but there's still an alignment does occur, then we can end up with something called an annular eclipse. We had one or two of those in the last couple of years. And what we're having today is this, a partial solar eclipse, where only part of the sun is going to be covered up from our point of view. Now, why don't we always get eclipses? Why, if the moon is going around the Earth once per month, why are we not seeing these eclipses every single month? Well, the answer to that is that things aren't perfectly aligned in our solar system. Yes, most of the objects in our solar system are confined to this remarkably narrow region of space, the solar system's disk, where the stuff in our solar system eventually formed and eventually turned into the planets and moons that we have today. But it's not all perfectly aligned. Some of it's slightly above, some of it's slightly below. If you imagine the orbit of the Earth as being one piece of paper and the orbit of the moon around the Earth being another, they're slightly inclined to one another, which means that sometimes the moon is just too far up above the sun from our point of view as observers here on the Earth. Sometimes it's too low in the sky from our point of view to actually cover up the sun. In our case, today, we've got a partial solar eclipse where the alignment's not perfect, but it's just grazing along the top of the sun and will block a small amount of its light. So what can we expect to see today? Well, we've got a graphic here to show you what the visibility of the peak is going to be in various different places in the UK. In general, if you're in the UK, the further you are to the northwest, the better your view is going to be. So we've got Belfast and Edinburgh here. They have around about 40% of the sun being covered by the moon. For Cardiff, slightly further to the southeast, that's going to have around about 35%. And for us down here in London, it's only going to be 30% of the sun which is covered. Still a very decent amount and definitely worth having a look for. But what about around the rest of the world? Well, the best places to see this eclipse are, as I said, some pretty sparsely populated places, which is not surprising in reality. With 2/3 of our planet covered in ocean and a large fraction of the land being sparsely populated as well, it's not really surprising that most of the time these eclipses are occurring where we can't really see them. So the best place that we've got, at least on this diagram here, is Cap Nouvelle-France in Canada, which is in Quebec, in the province of Quebec. That's going to have about 90% of the sun being covered. Some of the largest cities in the US that will have a view are Portland in Maine and Boston in Massachusetts. They'll have around about 80% of the sun is covered. If we go halfway across the Atlantic to Reykjavik in Iceland, that's more like 70% of the sun. And if we go further to the southeast of where we are, things get progressively lesser. So Paris in France, that only has about 20% of the sun being covered. Nonetheless, in all of those places, very much worth having a look. Now, how would you go about observing an eclipse for yourself? Well, in order to answer that, I'm actually going to bring Jake Foster out here to help me, and we're going to talk about some of the ways that you potentially could observe an eclipse for yourself. Jake, what's the ideal way to be observing?
Well, first of all, it's worth saying, I think, in just a second, we're
minor technical problems, but we're going to solve them right here. There we go.
This is what happens when you do live stuff.
Absolutely.
Everyone can hear me okay. Well, as you might be able to see here, Greg, I've got a stack of goodies with me,
yeah,
actually.
Yeah, very weird stack of goodies. Go on.
But the first thing to say, of course, is safety first, as always. And it may sound obvious to some people, but we really should state it again and again. It is not safe to look directly at the sun with the unaided eye. It can cause severe and sometimes permanent damage. I think we're having some more. Yes.
So the ideal thing to be able to use to observe the eclipse is actually a pair of solar eclipse glasses. And Jake actually does have a pair of those right here. Here we go. So tell me about these.
Yes, so these solar eclipse glasses have special lenses, special filters in them that block out 99.9999% of the sun's light.
I can't see you at all.
Exactly. So the only thing you should be able to see when you're wearing them is, in fact, the sun. So if Greg looks up at the sun, he can see it perfectly
Fantastic.
safe. And in fact, the filters it uses are very similar to the ones in our solar telescope at the moment, so the one that we are using to bring the eclipse to you. If people do have a pair of these at home, it's important to make a few checks first. First of all, they should have certification logos on them that say ISO or CE to indicate that they are all above board and well manufactured.
Absolutely.
As well as that, anytime you're using them, you should always check beforehand that the lenses don't have any cracks or creases in them, that they may have been compromised in some way. So you've got to make sure that they are safe. But if all of that is all good and above board, they can watch the eclipse for themselves directly this morning.
Now, here in the UK, about 25 years ago, we had a rather fantastic eclipse, the 1999 solar eclipse, which was actually total from a very small part of the UK. If they happen to have any solar eclipse glasses from all the way back then, are those still safe to use?
I'm afraid not, unfortunately. The material that the filters are made from do seem to degrade over time, so if they are more than 5 years old, say, it's just not safe. Don't take the risk.
Yeah. Modern eclipse glasses do tend to be more resilient. They can last a little bit longer, but even so, while we very much recommend reusing wherever it's possible, it's not worth taking the risk when it comes to the safety of your eyes. So, I don't have any solar eclipse glasses. I didn't prepare. So, what's my next choice for being able to observe?
Well, maybe you'd be interested in a little bit of simple make and do. So, what I have here actually is 2 pieces of paper, if you can hold those there.
Yeah.
1 piece of paper you make a very small hole in with a pin or a pen or a pencil, just a small circular hole. And then what you can do is hold the one with the hole in towards the sun and hold the blank piece of paper about 30 centimeters away. And if you get the angle just right, you should be able to, in fact, and you're giving me a nod as if it is working.
You won't be able to see from your point of view, but I assure you there is a tiny, tiny little vision of the sun with a tiny little bite being taken out of it. So that is indeed working as intended.
Yes, so this is a simple pinhole projector, and so this is indirect viewing of the eclipse. So you're not looking up towards the sun, you're projecting its light through that small hole to create an image of it that you can safely view for yourself.
Jake, I'm out of stationery supplies. I don't have any paper or card to hand. Am I out of luck?
You are not out of luck. What many people might not know is, in fact, they do all have, usually, pinhole projectors in their kitchens. And that is why I have brought this colander right here. Now, this actually is a pinhole projector in its own right because it is full of teeny tiny little circular holes. So, if you do the exact same thing, hold a colander up towards the light of the sun, and then hold out a piece of paper, or you can project it onto the ground or onto a wall, you should be able to see dozens of little partial eclipses happening.
Absolutely, you absolutely can. Yes, absolutely. So we've got dozens of different little projections of the sun appearing on this piece of paper. I'm going to turn it towards you. Maybe, you might actually just be able to see that that is indeed happening. And they do all have that little bite taken out from them due to the partial solar eclipse. Fantastic.
There we are. So that is how people can view it for themselves. And of course, as we say again and again and again, safety first, and sunglasses definitely not good enough.
Jake, I'm a hermit. I live in Greenwich Park. I don't even have access to a colander. Am I out of luck now?
You are still not out of luck. If you are even remotely close to a tree that has quite a few leaves on it, even trees can be pinhole projectors. So if the tree is leafy enough, then sunlight can come through the gaps in between the leaves in the trees and project the eclipse onto the ground. So it's worth trying, if you have a tree near you, to look in the shadow of the tree for tiny little projections of the eclipse.
Nature's own solar projector.
Absolutely.
How about that? Jake, thanks very much for that.
Thank you.
All sorts of different ways for you to be able to observe the eclipse for yourself. Plenty of ways to be able to see it for yourself. So do have a look at those, but also do keep looking at our own view through our telescope. Let's go actually and see the thing full screen so that you can see it in all of its detail. We have got the entire disk of the sun. We've got a large section in the which has been cut out at the bottom there. that is the moon blocking some of its light. We are around about 1/6 of the way through the eclipse at this point. We're moving nice and quickly through it, so we've still got a fair way to go before we reach the maximum point where 30% of the sun is going to be blocked out by the moon. Now, what about the sun itself? Because actually, as we look at this view, the sun itself does have a couple of features visible on it, things that we can actually see which are coming through our telescope as well. If you look towards about the 10, 11 o'clock position, right towards the edge of the disk of the sun, there is a dark spot right there. And although I can't see it for myself, if you look just below the center of the disk of the sun, hopefully you should be able to see a little cluster of dots as well. Those are actually surface features of the sun, things which are actually happening on the surface of the sun. And we're going to talk a little bit about some of those now. Now, we can't really see any of them at the moment through our view of the sun, possibly just because there aren't any, but there's a particular type of surface feature that appears on the sun known as a filament. A filament is a vast plume of gas that's been erupted off of the surface of the sun and is hanging in the lower atmosphere, and it blocks a small amount of the light. So it appears as sets of dark lines across the surface of the sun, indistinct, wispy dark lines. And there's a related feature called prominences. Prominences are the same thing, plumes of gas, but this time occurring right around the outside of the disk of the sun. And we've got a fantastic image of a prominence from here, from NASA here. And this is a huge plume of gas. It really is vast. You can see right at the top there, that's an image of the approximate size of the Earth in comparison. These things are absolutely huge. We can be talking vast quantities of material being thrown off of the surface of the sun. And if that prominence actually occurs facing towards us, so the disk of the sun is behind it, instead of being bright, it will actually appear dark from our point of view, and so we get a filament instead. But what about those dark spots that we actually saw on the sun earlier? Because they're clearly not filaments or prominences. What are they instead? Well, those are what we call sunspots. Sunspots are darker regions on the surface of the sun. They're a few hundred degrees Celsius cooler than the 5,500 degrees Celsius that the rest of the surface of the sun is. And as a result, they're putting out just a little bit less light. If you scooped that material off of the sun, held it well away from the sun, it would glow incredibly brightly, as it is doing right now. The thing is, in comparison to the rest of the sun, it's much, much fainter, and so it appears as a dark region. Now, a lot of these features are to do with the activity of the sun. The sun goes through a cycle of approximately 11 years of activity, from minimum through maximum and back to minimum again. That takes about 11 years to complete. And we're actually roughly at the peak of the maximum of the sun's activity at the moment. So there's a fair number of sunspots, fair number of flares, fair number of prominences, and a lot of material being thrown off of the surface of the sun, which is important for us here on Earth because that stuff flies out into the solar system. Inevitably, some of it hits our atmosphere and creates the aurorae. Now, the aurorae, or the northern and southern lights, as shown in this beautiful image taken by Laren Ray, an entrance into our Astronomy Photographer of the Year competition from a year or two ago. These are bright curtains of light, typically, that appear in the atmosphere, particularly in very northern and very southern parts of the Earth, where this material from the sun has smashed into the atmospheres, interacting, producing lots of light, and producing these beautiful aurorae, these beautiful lights in the sky. Here in the UK, we don't get those all too often, at least not if you're outside of Scotland, or the very northern tip of Scotland, I should say, except, of course, last year, we actually did get quite a lot of them, and there may well be some more as well coming. The activity of the sun is still fairly high, so it won't be surprising if we get quite a bit more. Now, if you want to learn more about the sun, you could certainly do worse than buying our ROG Illuminates book on the sun, written by one of our very own astronomers, Brendan Owens, who has left the observatory a few years back, but I caught up with him earlier in order to find out why it is that he decided to write a book on our very own star.
So I'm here talking with Brendan Owens, the author of The Sun book from our Illuminate series. Hi, Brendan.
Hi, Greg.
So you were actually once one of the astronomers here at the observatory, but you left a few years back. What have you been up to?
Well, apart from missing the Royal Observatory Greenwich very, very much, I have gone on a little journey. I am based over here in Dublin, in Ireland, and I started off with Science Gallery Dublin, part of Trinity College Dublin, working on a lot of cross-collaborative art science projects and European projects. So some really interesting work, keeping my love for astronomy wherever possible, having that in there. But then also moving on then to work with the Institute of Physics, which is currently where I am. So I'm public engagement manager there, and one of the public engagement team, and looking after activities that are inspiring the next generation of physicists and breaking down barriers to inclusivity.
That's fantastic work. Now, towards the end of your time here at the observatory, you, of course, wrote the Sun book, from our Illuminate. What made you choose the topic of the sun?
That's a very good question. My short answer probably could be because someone asked me to, but no, it is going for a more personal passion place. I caught the bug for astronomy communication, science communication at Armagh Observatory in Northern Ireland. And as I went back there every summer, I started to get involved in some of the solar physics work there. So particularly looking at small magnetic features on the sun. So I've kept that love for solar physics all the way through and brought that with me to Greenwich as well. And I know where you are right now is next to the beautiful AMAT. And so worked with that telescope, and it was had a few different reconfigurations, but was using a solar instrument there and working with Flamsteed volunteers as well. So I've kept that passion, and I've just been really interested in it. Even though I don't deal well with the sun on holidays, I do tend to suffer from a lot of sunburn.
You and me both. You and me both. Now, being present in the sky every day, people could reasonably assume that we know an awful lot about the sun, perhaps all there is to know. What more is there really left to learn?
It's a very good question, because you think that something so close, so easily identifiable in the sky, that surely we do know everything, but there's still some pretty big mysteries. The sun is, as I discovered writing the book, it's more and more complex than you could imagine. So there's a lot around the internal configuration of the sun that we don't understand, a lot around the magnetic field. So one of the more complex problems is we understand that there is a cycle. We see sunspots appear, move position on the sun, and then disappear. And the cycle starts again. But that sort of internal mechanism of how the magnetic field of the sun flips, we still don't know all the pieces to that puzzle. So that's a pretty big one. And then the other one, which is really bamboozling, is something called the coronal heating problem. And there's a few suggestions for it, but the way I describe it in the book is the strange thing of, if you consider a campfire, you would expect that you go further away from the fire, it's going to cool off. You don't expect that you're close to the fire, but people who are further back get incinerated. And that's kind of a little bit with the sun. So it starts off with a 15 million degree core temperature. By the time you get to the sort of surface of the sun, if you like, the photosphere, it's about 5,500 degrees Celsius. But once you go higher and further away from the sun, in the atmosphere of the sun, it's 2 million degrees Celsius. So there's a number of suggestions, but again, not all the puzzle pieces are fitting into place.
Now, solar eclipses, we're trying, fingers crossed, to observe one of those today. They can be absolutely spectacular sights, but are they really useful to solar physicists, to astronomers? Is there anything we can learn from them?
Apart from being very awe-inspiring, there's a lot I think we can still learn from solar eclipses. Even though there's technology these days that can artificially block out the sun, and called coronagraphs. They're usually just a disk of material and that blots out the sun and allows you to see the corona, the outer atmosphere of the sun. It's not ideal because it actually blocks out the area of the atmosphere of the corona closer to the sun's surface. So there's a blind spot, and that blind spot you can only peer at during a naturally occurring total solar eclipse. So that's really key. And we can study effects that happen to our atmosphere when the sun is blocked. So compare what the solar radiation is doing to our upper atmosphere when it's in the shadow of the moon compared to when it's not.
So solar eclipse is still very much useful today. Unfortunately, this particular solar eclipse, we're not going to be able to do that with. It's only a partial solar eclipse, but still, when we get total solar eclipses, fantastic things to be able to observe for scientists as well. But about this eclipse, are you going to be looking out for it today?
Actually, because I know it's Mother's Day tomorrow, but my mum is coming up to Dublin, so we're probably going to be walking the streets of Dublin in a moment and having a look for it. But I have to say the Irish weather is not usually on our side, and it is forecast to be raining.
Oh, fantastic!
So not ideal, but I will look for. I will keep a little bit of batter film or my solar eclipse glasses to hand, just in case there's a gap in the clouds.
And if all goes wrong, you can at least try and tune into it here on the ROG.
100%. Absolutely. I'll have my phone out for that. Thank you.
Brendan Owens, thank you very much for joining me.
Thanks so much, Greg. It's been a pleasure.
Brendan Owens there of the Institute of Physics. Thank you very much for joining us. If you are just joining us now, welcome to the Royal Observatory Greenwich partial solar eclipse live stream. You've just been listening to an interview with Brendan Owens, the author of The Sun book from our ROG Illuminate series. If you're interested in getting one of those or one of the other books within that series, all written by astronomers here at the Royal Observatory, you can take a look at our shop on our website, shop.rmg.co.uk, or you can have a look at a whole load of good retailers, both on and offline. Now, while the live stream has been going on, we've had some questions coming in through our chats, which I'm going to take some time now to answer a few of those. If you do have any questions about the solar eclipse, about anything to do with observing one of these, please do send them in to us and we'll do our best to answer them. We'll have another big block of them towards the end of the stream. So the first question we've got here is a very simple one. Why is it dangerous to look at the sun? Very simply, it's very dangerous for your eyes. It can damage your eyes quite badly. You may have noticed that if you've looked at a fairly bright torch or something along those lines, you might have left a small imprint in your eye that takes a little while to go away. That is very, very temporary damage to the retina of your eye, making it so that for a little while at least your eye is a little bit less sensitive in that region. Now that fixes itself relatively easily. The problem is the brighter the light is, the worse the damage becomes, and the sun is an extremely bright source of light. The human eye just is not designed to look directly at it. If you have ever thought that I've looked at the sun before, it's gone fine, great, well done. But that's not a good thing to test again, because it only has to go wrong once for you to be in serious trouble. So it really isn't worth it. In reality, if something is painful for your eyes, if you are squinting, if you're really struggling, then you're definitely doing yourself some amount of damage. And the danger is that it will become permanent damage and you will damage your eyes permanently. We just don't want that to happen. So be very safe when you are trying to observe this solar eclipse for yourself. Make use of solar eclipse glasses that have been checked, that are definitely certified. Make certain that you're using a solar projector or something along those lines, or just have a look at our own view through our telescopes. We are actually now showing you the timeanddate.com stream, which we've partnered up with for this particular eclipse. And we've got a handful of different views from different places across the world, some in Canada. We've got, in fact, our very own one from London here in the UK, and another one from, which is the main one, which we've got here, which has a lot of detail on the surface of the sun. They've done very well to get that view there. What about other questions? How often do solar eclipses happen? Kind of two questions rolled into one there. How often do solar eclipses happen from the point of view of a single observer, and how often do they occur from the point of view of the entirety of the Earth? Well, from the point of view of the entirety of the Earth, a partial or total solar eclipse is expected to happen maybe once every year or two, something along those sorts of lines. But for a specific place on the Earth, they are extraordinarily rare. One specific place is extremely unlikely to be able to see a total solar eclipse, I'm referring to here, more than once in a century or two. It is a very, very rare event, in fact less than that, for any part of a particular place to be able to see a total solar eclipse. Partial eclipses, rather more common. You need a less perfect alignment. You need to be less perfectly in the shadow of the moon in order to be able to see them. But the total solar eclipses are extremely rare and very much worth having a look for if you get the chance to see one. We've also got a question here. Are solar eclipses linked to lunar eclipses? Absolutely they are. Now, lunar eclipses are basically the reverse of a solar eclipse. This is where the Earth passes, where the moon passes into the shadow of the Earth. So the alignment is the same, it's just the moon is on the other side of the Earth, and the shadow of the Earth appears onto the moon, blocking out its light, and what would normally be a full moon at that time, because that part of the moon should be entirely lit up, goes dark. But it doesn't go entirely dark. It goes dark with a red sheen to it, a red tint to it, because a small amount of the light of the sun manages to get passed around the atmosphere of the Earth, is bent by the atmosphere, and in fact what you're seeing is the colour of the sunset or sunrise being projected onto the surface of the moon. Now, is there a link between lunar and solar eclipses? Yes. At the beginning of today's stream, I told you that we don't get an eclipse every single month because the plane of the solar system and the plane of the moon's orbit around the Earth are not perfectly aligned with one another. If they were perfectly flat compared to each other, then we would get a total solar eclipse, or a solar eclipse at the very least, every single month. But we don't, because they're slightly inclined. Everything needs to be perfectly aligned. In fact, from your point of view, here is exactly where we would end up with a partial solar eclipse. If I were the sun, this was the moon, and over here was the Earth, because the middle of this orbit is perfectly aligned with itself. And what would happen is you'd get a total solar eclipse with the moon on one side of the Earth, and you'd get a total lunar eclipse on the other side. So generally speaking, you actually get solar eclipses and lunar eclipses following along within 2 weeks of each other. Basically, the other side of the moon's orbit, you end up with a lunar eclipse instead. Do keep your questions coming in. We'll be answering more of them later on. Now, earlier today, Brendan was talking about talking about some of the research that can actually be done with solar eclipses, and that involved looking at the atmosphere of the sun. The atmosphere of the sun is remarkably difficult for us to be able to access because it is so much fainter than the surface of the sun, the photosphere, the part where the majority of the light is coming from, just overshadows everything with the much, much fainter corona, the outer atmosphere. And we've got a fantastic image again from our Astronomy Photographer of the Year competition, this time taken by Phil Hart and Colin Legg. Now, this is an image of a total solar eclipse that happened a year or two ago. And around the outside, you are seeing those countless streamers, as he's referred to them, these white lines. That's actually the outer atmosphere of the sun. And there's a bit of a weird thing going on with that. You see, it extends much, much further from the surface of the sun, millions of kilometers from the surface of the sun, and yet is considerably hotter than it. It can be well over 1 million degrees Celsius when the surface of the sun is only 5,500 degrees Celsius, if only can really be used there. That's still incredibly hot, but it's not 1 million. So what is going on there? Well, in all honesty, We're not absolutely certain. We do have some ideas, but it's really not clear exactly why the atmosphere of the sun is so much hotter than the surface. And solar research is really key to us to be able to answer that question and making use of eclipses to be able to make those observations, because the technology that we have still makes certain parts of the sun's atmosphere really difficult to access. Now, this was true even going back 100 to 200 years when the advent of astrophotography was occurring. And there is a person, a key person, who is close to the hearts of the people here at the Royal Observatory Greenwich, who was instrumental in understanding the sun and working on those eclipse expeditions, and that was Annie Maunder. Annie Maunder was a human computer. This was a position at the Royal Observatory and many other observatories around the world, because this was long before the invention of the electronic computer or the calculator. So all calculations had to be done by head and by hand. And unfortunately, that task was generally given to those who were considered to be less important, which did mean very early astronomers very early in their career, and also to women. That was just the situation that existed at the time, around the turn of the 20th century. But the reality is that Annie Maunder was a fantastic astronomer and astrophotographer in her own right. She produced all sorts of images of the nights of the sun in order to try to understand what was going on within it. She also worked on a series of solar eclipse expeditions to head out to those remote parts of the world where a solar eclipse was happening. They were predictable. You could send things out in advance, get everything set up as a miniature observatory, and then take your observations during the handful of minutes that you actually have to be able to get those observations. So a very difficult thing to organise, and she was instrumental in doing so. Now, Annie Maunder's birthday, her anniversary, is actually coming up. It's only in 2 weeks' time, on the 14th of April. And we're going to be celebrating that here at the Royal Observatory Greenwich with a day dedicated to her life, her work, and her legacy. We're going to be doing solar observing here on site, so if you've missed out on seeing through our solar telescopes today, do come along on the 14th of April during the day to be able to see that. And we even have an event in the evening, a panel discussion where we're going to be talking about the challenges that she faced as a woman in the early 20th century, the late 19th century and the early 20th century, trying to be an astronomer, trying to be taken seriously by the community. And we're also going to be talking about her legacy, which we are proud to be part of here at the Royal Observatory, because we have a robotic modern telescope called the Annie Maunder Astrographic Telescope. Now, this is it. It is a telescope that we have been using to take images of the night sky, and we are going to be revealing some never-seen before images taken with this telescope in the last 6 months or so at that very event. So if you would like to come along to that panel discussion, have a chance to talk with historians, curators, and indeed with myself about the life and work of Annie Maunder, please do find those tickets on our website at rmg.co.uk. Now, we have been observing we've been observing the sun even today with our telescope, a solar telescope. But on the back of the solar telescope is a camera, a very specifically designed camera to be able to take images of the sun. And solar astrophotography is not an easy thing to do. It does require quite sophisticated equipment in order to be able to do, at least to do well. And we do actually have an image taken on our Annie Maunder Astrographic Telescope, in fact, with this very telescope that was once mounted on that. And here it is. This is an image of the surface of the sun. This time it's been processed through. So the image that you've been seeing today throughout the entirety of this stream, that has been a live view of the sun and has all sorts of defects, all sorts of issues with that particular view, just through the nature of taking a live image. But what we can do is we can then take each of those individual frames, stack them on top of one another, and with some fancy computer wizardry, which only pulls out details that are actually there, we're not adding anything to the image, we get a beautiful view like this. And if you see down in the bottom left-hand corner, that's one of those prominences I was talking about earlier today, these vast plumes of gas extending off the surface of the sun. That one in particular is about twice the size of our planet Earth. It's a very, very large plume of gas being flung off the surface of the sun. Now, as good as the images that we can get with our telescopes here are, they pale in comparison to the beautiful images that are being produced by the astronomers who enter our Astronomy Photographer of the Year competition. And in fact, we have an example of one of those right here. This is, in fact, the winner of last year's competition. This is distorted shadows of the moon's surface by Ryan Imperio there. And this was taken during an annular eclipse, so almost a total solar eclipse, but the moon is slightly too far away to cover the entirety of the sun, so we end up with this large ring of light. But what Ryan has done here is he's taken a series of images as the moon is just beginning to part the edge of the surface of the sun, and those dark parts that you can see, those large peaks which appear to be like fingers stretching in from the side of the image, those are in fact mountains on the surface of the moon. If we have a look back at our own view through the telescope, hopefully we will actually be able to see there is a little bit of cloud around. I don't know if it's actually coming through, but maybe, I can't see properly, I'm afraid. It's a little bit too faint for me to be able to see, but around the edge of the moon, you might be able to see that it's not a perfect circle. There is a slight feathering to it. This might be a better view to be able to see that. Here we go. So around the outside of the moon, you might just be able to see that there is a very, very, very slight feathering to it. That is actually details on the surface of the moon. Those are hills, valleys, mountains, craters on the moon, which are actually being seen from the side, being able to see that the surface of the moon is far from smooth. It does have a lot of texture, a lot of detail to it. Now, if you are interested in seeing more of the Astronomy Photographer of the Year competition images, well, I've got a treat for you here. We have a video here from Pauline Woolley, who was one of the entrants into our Astronomy Photographer of the Year competition a few years back, to tell us all about the image that she took of the sun.
My artwork is a relationship between sky, time, place and astronomy. I'm particularly interested into our relationship to our ancestors and how they would have perceived the night sky. Trees are a map to our past, and there's been scientific research in tree rings and how they can show an element called carbon-14. And so I was interested in this in terms of that link between us being made of carbon and also the time element of tree rings. I kind of started looking at solar data online and was just like, gosh, there's all this information that you can pull down and start creating things with. And I just thought, well, we're at the beginning of solar cycle 25. What would it look like if I took an image from the first of the month until, I don't know, February of 2021 and laid them? How would that look? And it started to look like the rings of a tree. I wanted to be a scientist when I was a youngster, and I didn't follow that pathway. So being shortlisted and then winning the category is an amazing achievement for me, and hopefully inspiring other women and other girls to look up at the night sky. And if you've got that creative flair, go with it. It's a really important journey, and it's one that's really, really worth taking.
Solar Tree there by Pauline Woolley, a fantastic entry into our Astronomy Photographer of the Year competition a few years back. If you are just joining us, you are listening to our solar eclipse live stream from here at the Royal Observatory Greenwich, and you just watched a video all about one of the entrants into Astronomy Photographer of the Year competition. Now, the competition for this year actually just finished a few weeks back, which means that our judges are now deep in deliberations, attempting to work out of the incredible array of beautiful images that we have, which one is going to win our competition. And the details on all of that will be revealed over the course of the next few months. If you want to see the entries into our last year's competition, we do still have our exhibition down at the National Maritime Museum, which is free for you to enter, so free for you to go into. So please do go down there, have a look at that, and take a look at the images that we have from last year's competition. Now, it has become a little bit cloudy here at the Royal Observatory Greenwich. I'm still squinting a bit because we're still getting a fair amount of the sun coming through. But I can't tell whether we're actually getting a view of the solar eclipse through our telescope at the moment. If we have a look at that full screen, we'll be able to see whether we've got a nice view of the eclipse. It does appear to be there somewhere, but it is a little bit on the faint side. That's just a reality of the clouds which are coming across. We've got thin clouds coming, which we were expecting, unfortunately, but we've been incredibly lucky so far to be able to see it. But I am still seeing the shadow of the moon over the sun there, so that's really good to be able to see. And let's have a look also at our partners at timeanddate.com, who have been observing the eclipse for themselves in a number of different places around the world. We actually do have our view up there in the top right. We've got Siena in Italy on the right middle there, who seem to be having a similar problem to us now with some clouds coming across, but we do have a fantastic view of the sun right in the center. We've got that sunspot up about the 11 o'clock position that we have on our view as well, and a few other sunspots visible, and a lot of detail on the surface of the sun as well. The Canada view, which we've got in the top right hand corner there as well, not quite so much detail on the sun, but a very, very stunning, striking view of the disk of the sun being covered by the moon. Now, we are only about 10 or so minutes away from the peak of the eclipse for many people across the world, the point where the largest part of the sun is going to be covered by the moon. From our point of view here at the Royal Observatory Greenwich, it's only going to be about 30% or so, still a fairly sizable chunk of the sun which will be covered up, but we are very much getting towards that. You might be thinking, though, as we're coming towards the end of the loud part of the stream, where I'm going to be talking to you and moving into the quiet stream in just about 10 minutes' time, what about the next eclipse, your next chance to be able to observe an eclipse at some point in the future? Well, there is another partial solar eclipse happening later this year. It's in September. However, if you thought this eclipse was difficult to observe, just wait till you hear about this one. You see, this particular eclipse happening in September is only going to be visible in the southern hemisphere, and it's only going to be visible from the very southeastern tip of Australia. New Zealand is probably the most accessible, most highly populated area that's actually going to have a view of it. A few of the southern Pacific islands will have a view, but most of it will be over Antarctica. So for the 10 people who happen to be out in Antarctica in September, I very much hope that you enjoy your fantastic view of the partial solar eclipse. We will be very jealous here in the Northern Hemisphere, where we don't have a view of it at all. That's just how it goes sometimes. These things are only visible in certain parts of the world. What about the next time that we can actually see an eclipse from here in the UK? Well, we don't have to wait all that long. Next year, August the 12th, if I remember correctly, is going to be the next partial solar eclipse that is visible from here in the UK. And that one is, in fact, a total solar eclipse elsewhere. But don't feel too bad that we're missing out on the total solar eclipse here in the UK, because we do pretty well. It is going to be a 90% solar eclipse from our point of view here in the UK. So 90% of the sun will be covered by the moon on that particular day. that is very much worth looking for, very much a chance for you to be able to see a rather unusual event for us. So do take a look out for that. If, however, that's not quite good enough for you and you do want to see the beauty, the majesty of a proper total solar eclipse, well, you're going to have to get on a plane or a boat, because you're going to have to go to Greenland. Greenland get it again next year in August 2026. Iceland again get a view as well. The western portion of Iceland is going to have the total solar eclipse. And Spain. So the northern and central parts of Spain will also have a view. So those are the three places that actually have land on them that you can actually try to observe. Alternatively, if you happen to have access to one, try using a boat out in the middle of the North Atlantic. That would get you a view as well. I have asked that we consider that for here at the Royal Observatory, but apparently quite a few of our astronomers are seasick. So I don't think that's going to be happening anytime soon. So what about a total solar eclipse? Come on, when is the next time that we're going to be able to see a total solar eclipse from here in the UK? 2090. 2090. Yeah, it's a very long way off. As I say, these things are extremely rare, and even then, it's not going to be a total solar eclipse across the entirety of the UK. Oh no, it's going to be the southwest again. Cornwall, Devon, that sort of place that's actually going to have the best view of that total solar eclipse. So if you were there for the 1999 one and somehow managed to make it all the way to the 2090 one, you'll be in the same place to observe both. Now, we are very much coming towards the end of our stream. We're just going to have a look at some questions that have come in during our stream here. They're coming along to me now. Here we go. So, does the Royal Observatory organise public events to be able to view the sun and solar eclipses? Yes, we absolutely do. We actually do have people here at the observatory observing through our solar telescopes, observing the surface of the sun with some of our telescopes right now as we speak, although, as I say, with the sun slightly covered up, it's not quite as good as it was, although as I say that, the sun's coming back through, so that's fantastic timing. But what about generally? Well, we do have that Annie Maunder event happening on the 14th of April. Fantastic time to be able to try to observe the sun there during that day. The Annie Maunder's anniversary of her birth, when we're going to be celebrating the life, legacy and work of her. We're going to be doing solar observing, and that's actually going to kick off a very early start to our solar observing sessions for the entirety of the rest of the year. So every weekend from that point forward, we are going to try to have solar telescopes out here at the Royal Observatory for you to be able to see. And on top of that, right at the very beginning of today, we had an interview with Mike Maynell from Flamsteed Astronomy Society. They run their own solar observing events here at the Royal Observatory as well. Very much worth coming along to. Those will occur typically on Fridays or Saturdays, Sundays if things go wrong, if the weather's poor. So do try to come along to some of those. All of the details for all of that can be found on our website, rmg.co.uk. We've got, will the eclipse make the moon hotter as it is closer to the sun? An excellent question. In reality, no, not a whole lot. So the thinking here is that because the moon is closer to the sun during this eclipse, that would therefore make the moon a little bit hotter. But the reality is the moon is in no specifically different position to where it was a day ago, to where it will be in a day from now. It's not really much closer to the sun. No, the thing that determines the temperature of the surface of the moon is its day and night cycle. When we look at the moon here with our solar eclipse view, we actually see the rear side, the side of the moon which is facing towards us, that is dark, and that means that the side is not being lit up by the sun. That's what we call the new moon at the moment, the dark part of the moon. The other side is lit by the sun and is extremely hot. And because of the day and night cycle on the moon taking an entire month to complete, we actually get two entire weeks, 14 days of constant sunshine on that side of the moon, or a specific part of that side of the moon, which means that the temperature on the surface of the moon on the other side is over 100 degrees Celsius, whereas the side facing towards us, that's more like minus 150 degrees Celsius. The differences in temperature between the far side and the near side of the moon is absolutely massive. Now, a moment ago, someone was asking about observing happening here at the Royal Observatory, and in fact, we've had a camera out and about, and we're going to go live to an interview with one of the people who are actually observing through telescopes here at the Royal Observatory right now.
We're in the courtyard outside Flamsteed House with...
Alessia.
Ruby.
Tiffany.
Where have you come from today, guys?
We live in London, but I'm from Italy. Ruby's from London, half Nigerian, half Italian. And Tiffany.
I'm from Australia.
Ooh, that's far away. Did you know it was going to be the eclipse today, or partial eclipse?
Actually, no, it's such a nice surprise.
Online, because Ruby loves the sun and the planets. And then we got here and discovered that we've got this special event.
Have any of you seen an eclipse before, or a partial eclipse?
I haven't.
I have actually once. It was very beautiful.
Where were you?
I was in Italy. We threw a party afterwards. It was really fun. Yeah, everybody was scared at the beginning. I remember the news saying, you've got to be careful, this and that. And then it was just fun, really.
Was it a solar eclipse or a lunar eclipse?
Solar.
Okay, so it's during the day?
Yeah.
Yeah.
Well, thank you, guys.
Pleasure.
And we'll go back to you.
Thank you.
Fantastic to hear from some of the visitors who have clearly been enjoying their view of the solar eclipse today. We are actually at pretty much the peak of the eclipse. It should be happening right about now. So our view is not ideal with the clouds slightly in the way, but hopefully you can still see that the sun's disk is still there. The moon is certainly blocking a large fraction of it. This is about 30% of the sun's surface is being covered by the moon there. And we do have the peak of the eclipse occurring right at this very moment. Now, we are very much coming now to the end of our loud part of our stream today. We are going to keep that view of the solar eclipse visible to you for the entirety of the next hour. The end of the eclipse won't be until a few minutes after midday. But there are just a few more things for me to say before we finish for today. A huge number of people to thank for putting together this stream. We've got our fantastic AV team who are hiding away in one of our galleries with all of the tech equipment, keeping all of this running. Absolutely fantastic work by them. We also have our web and social media team who have been working to make certain that we've got your questions from you, that the stream is all working properly, and that we've got fantastic visuals going out to you as well. A big thank you also to Tanya and to Jake, my co-star, who has been working tirelessly to bring you the image of the solar eclipse, and of course to all of the staff here at the Royal Observatory Greenwich for their fantastic efforts as well. We're going to be keeping the view of the solar eclipse with you for the entirety of this time, but for now it's time for me to say goodbye. I very much hope you've enjoyed the eclipse stream today. Thanks very much. See you soon. you.